14,000 meals a day means tons of trash on a ship that can't dock for months. Dump one plastic bag overboard, the Navy breaks international law. Store one load wrong, shipboard fire risk. The solution is a zero-discharge system most never see. Pulpers that liquefy food, presses that bake plastic into bricks, tanks that hold sewage until miles offshore. This is how carriers stay combat ready. But here's what most people don't get. A carrier isn't just a warship. It's a floating city with restaurants, hospitals, workshops, and offices. Every one of those spaces makes trash. Food scraps from the galley, plastic wrap from the supply line, batteries from the avionics shop, medical waste from sick bay, oil from the fryers, cardboard from the stores, glass bottles, metal cans, sewage from 5,000 people. None of it can just disappear. So the Navy built a system, not one machine, a whole ecosystem. It starts the second a sailor scrapes a plate. It ends when a contractor hauls sealed containers off the pier. In between, trash gets sorted, ground, baked, crushed, labeled, stored, and timed to legal distances from shore. This is that system. The first rule of carrier waste management: don't mix the streams. Walk into any galley or mess deck and you'll see them. Color-coded bins, placards on the bulkhead, plastics here, food waste here, metal and glass here, cardboard here, batteries and hazmat. Don't even think about it, take it to the hazmat locker. Why? Because one greasy napkin in the plastic bag ruins the whole load. One soda can in the pulper jams the grinder. One battery in the trash compactor starts a fire. The system only works if sailors sort at the source, so training starts in basic. Culinary specialists learn it in A school. Deck division gets refresher briefs. Watchstanders audit the bins. If someone dumps a pizza box into the plastic stream, they get corrected. Fast. Here's how it breaks down. Food waste. Plate scrapings, vegetable trimmings, coffee grounds, bread crusts, anything that was once alive and edible. This goes into dedicated bins that feed the pulper. Plastics. Shrink wrap, food packaging, utensil wrappers, bags, bottles. Anything polymer-based. This stream is sacred. It never goes overboard, ever. Metal and glass. Soda cans, soup tins, ketchup bottles, broken dishware. These get rinsed if possible, tossed into bins that lead to the compactor. Cardboard and paper. Shipping boxes, paper towels, napkins, office printouts. Some of it gets shredded, some gets pulped with the food waste if it's food soiled. Hazardous and special streams. Used cooking oil goes into sealed drums. Batteries go into fire-safe containers. Medical waste, needles, bandages, anything with blood or bodily fluids goes into red bags that get incinerated ashore or treated as hazmat. Chemical cleaners, paint, solvents, electronics, all tracked, labeled, logged. Every stream has a chain of custody. Every container has a label. Every offload has paperwork. Because when the ship pulls into port, local contractors and environmental inspectors check. If a hazmat drum is mislabeled, the ship gets cited. If a plastic bag shows up in the food waste, the whole batch might get rejected. Sorting isn't just good housekeeping. It's compliance, it's safety, it's how the system survives. And it all starts at the plate, so the food waste is sorted. Now what? It goes to the pulper. Think of it like an industrial garbage disposal, but bigger, louder, and meaner. Sailors dump bins of scraps into a hopper. The machine grinds everything into a wet slurry. Water mixes in. The result looks like chunky soup, smells worse. Then the ship waits. Here's the law. The Navy follows MARPOL Annex 5, international rules written by the International Maritime Organization. Annex 5 says you can't discharge plastics at sea. Period. No exceptions. But food waste? That depends on where you are and how small the particles are. If the ship is close to shore, inside 12 nautical miles in most cases, the pulped food stays on board. It sits in holding tanks or gets stored until the ship moves farther out. Once the ship clears the legal distance, the crew discharges the slurry overboard. The ocean is big. The particles are small. Microbes break it down. The environmental impact is considered minimal under the rules. But there are special areas: the Mediterranean, the Baltic, the North Sea, parts of the Caribbean. In those zones, even ground food waste has stricter limits. The ship has to be farther from land, or the waste has to be ground finer, or discharge isn't allowed at all. So the navigation team and the environmental officer track position constantly. They log every discharge, they calculate distances, they check charts for special area boundaries, they coordinate with the bridge. Because if the ship dumps food waste inside the restricted zone, that's a violation. International citations, fines, diplomatic headaches, mission delays. The pulper itself is simple. Feed it, grind it, discharge it when legal. But the timing? That's the hard part. And timing is everything. Why bother with the pulper at all? Why not just store the food waste like everything else? 3 reasons. 1. Volume. A carrier generates hundreds of pounds of food waste per meal. 3 meals a day plus mid-rats for the night shift. That adds up fast. Pulping reduces the volume by mixing it with water and breaking it down. Easier to handle, easier to store if you have to hold it. 2. Pests. Rotting food attracts bugs and rodents. On a ship, that's a nightmare. You can't have rats chewing through cables or cockroaches in the berthing. Pulping and flushing the waste kills the problem at the source. 3. Smell. 5,000 people in a steel box. Ventilation is good, but it's not magic. Let food waste sit in bins for days and the whole ship knows. Pulping keeps the air breathable. So the pulper does more than manage trash. It keeps the ship livable. But it only handles the organic stream. Everything else, the plastics, the metals, the cardboard, needs a different solution. Plastics are the problem child of shipboard waste. You can't burn them safely without specialized incinerators most ships don't have. You can't discharge them. MARPOL bans it worldwide. And you definitely can't let them pile up loose in a storage compartment on a warship where space is tighter than a submarine's bunk room. So the Navy invented a solution: the plastic waste processor. Here's how it works. Sailors collect plastics in designated bags throughout the day, shrink wrap from pallets, food packaging, bottles, utensil sleeves, bags within bags. All of it goes into the PWP feed. The machine heats the plastic, not enough to melt it into liquid, but enough to soften it. Then it applies pressure, tons of it. The plastic compresses, fuses, and cools into a solid disc. Think of a hockey puck, but bigger. Depending on the model and the load, these discs can be 8 to 12 inches across and a couple inches thick. Hard, dense, stackable. One disc can hold a day's worth of plastic waste from an entire section of the ship. That's the magic. What used to take up 3 trash bags now fits in one rigid unit you can store like a dinner plate. The discs get labeled, date, section, sometimes a manifest number. Then they go into fireproof storage lockers, stacked vertically or horizontally depending on space. They sit there until the next port call. No smell, no pests, no risk of discharge. Just inert polymer bricks waiting for a pierside contractor to haul them away for recycling or disposal ashore. Here's why this matters. Before the PWP, the Navy had a plastics problem. Ships would bag the stuff, but bags take up space. They tear, they leak, and they're a fire hazard if they're near heat or electrical gear. Storage was a nightmare. And the temptation to accidentally lose a bag overboard, that happened. Not officially, but it happened. MARPOL Annex the 5 changed the game. When the international ban on plastic discharge went into full effect, the Navy needed a compliance solution that actually worked at sea. The PWP was the answer. Now it's standard gear on carriers, amphibs, and larger surface combatants. Smaller ships use different methods, compactors, incineration ashore, but the principle is the same. Plastics stay on board, period. And the discs prove it. When the ship pulls into port, environmental inspectors can count them. Check the logs. Verify that every ounce of plastic generated during the underway is accounted for. No gray area, no shortcuts, no ocean dumping. The PWP does one job, and it does it perfectly. It turns a compliance headache into a storage solution. But plastics are only one stream. Metal, glass, cardboard, oil, hazmat, batteries, medical waste, and human waste all need their own pathways. The rest of the waste streams follow the same ironclad rule: handle it right, store it safe, offload it legal. Metal and glass go into compactors. Rinsed soda cans, soup tins, ketchup bottles, broken plates, light bulbs. The compactor crushes them into dense bales or pucks, reducing volume by 70% or more. Those bales get wrapped, labeled, and stacked in storage until port. Depending on the port and the contract, some of it gets recycled. Some goes to landfill. Either way, it goes ashore, not over the side. Cardboard and paper get shredded or pulped. Big shipping boxes from replenishment day get broken down, run through a shredder, and compressed. Food-soiled paper, napkins, pizza boxes, paper towels can go into the pulper with the food waste if the environmental officer signs off. Clean office paper might get held for recycling in ports with the infrastructure. The goal is the same: shrink it, store it, move it. Used cooking oil is a hidden giant. Carriers have galleys running 3 meals a day plus mid-rats. Fryers run non-stop. That oil has to go somewhere. It gets filtered, cooled, and pumped into sealed drums. Those drums are treated like hazmat, labeled, logged, and offloaded to certified contractors. Some ports have programs that convert used cooking oil into biodiesel. Others dispose of it as waste. Either way, it never touches the ocean. Hazmat and special waste bourrin streams are locked down tight. Batteries, lithium, alkaline, lead acid go into fireproof containers in the hazmat locker. Paint, solvents, cleaners, electronics, fluorescent bulbs, anything with toxic or reactive materials gets logged on a manifest and stored in compliance with Navy and international hazmat regulations. When the ship offloads, the contractors need the paperwork to match the drums. One mislabeled container can delay the whole process. Medical waste is its own beast. Needles, syringes, blood-soaked bandages, surgical gloves, anything that came out of sickbay or the dental clinic, it all goes into red biohazard bags. Those bags get sealed, labeled, and stored in a locked space until the ship reaches a port with certified medical waste disposal. No exceptions, no shortcuts. Infectious waste is treated like the biological hazard it is. And then there's the waste nobody likes to talk about: sewage. 5,000 people living on a ship means 5,000 people using heads, showers, and sinks. That generates 2 kinds of wastewater. Black water. Sewage from toilets goes into the CHT system. CHT stands for collection, holding, and transfer. Waste flows through pipes into holding tanks. When the ship is close to shore, those tanks stay sealed. Nobody discharges black water inside 3 nautical miles from land. That's the baseline rule, though some areas have stricter limits. Once the ship clears the legal distance, the crew can discharge. The sewage goes through a treatment process: maceration, sometimes disinfection, depending on the system, and then it's released overboard in compliance with international and US regulations. CHT management is tightly controlled. Engineers monitor tank levels, the bridge track's position. The environmental officer logs every discharge. Alarms go off if a valve opens too close to shore. Because an illegal sewage discharge isn't just a fine, it's a pollution incident that can make international headlines. Gray water. Water from showers, sinks, and galleys has looser rules, but it's still regulated. Depending on the region and local laws, gray water might be discharged underway or held until the ship is farther offshore. Vessel discharge standards vary, and carriers operating in foreign waters follow host nation rules on top of US Navy policy. When the ship pulls into port, the waste ballet begins. Contractors arrive with trucks, pumps, cranes, and manifests. Plastic discs come off. Metal bales come off. Hazmat drums come off. Used oil drums come off. Medical waste comes off. CHT tanks get pumped if needed. Everything is counted, weighed, and logged. The supply department coordinates. The environmental officer signs off. The command gets a compliance record that proves the ship followed every rule from the day it left until the day it returned. And then the cycle starts over, because tomorrow, the galley will serve 14,000 meals again. The bins will fill again. The pulper will grind again. The PWP will press again. The compactors will crush again. The tanks will fill again. The floating city makes trash every single day. But the system, the sorting, the machines, the timing, the laws, the logs, keeps it from becoming a crisis. It keeps the ship clean. It keeps the crew safe. It keeps the mission on track. And it keeps the ocean cleaner than it would be if 5,000 people were just throwing bags over the side. That's the hidden machine under the mess decks, the one nobody sees, the one that turns a mountain of trash into a managed, legal, mission-ready process. Now you know how a carrier handles it. If you want the deep dive on one of these systems, how a pulper actually works, or the engineering behind the plastic waste processor, or what happens when CHT goes wrong, drop a comment and tell me which one. I'll break it down with diagrams and real-world failure modes. And if you want more behind-the-scenes carrier operations, hit subscribe. Part 2 is already in the works.